Welcome to video 3 in the sequence, pun intended. We will be working out some problems that deal with arithmetic and geometric sequences. Well, let's begin. Write a rule for the arithmetic sequence that has a common difference of 4 and a sub 4 is equal to 16. The key word here is arithmetic sequence, because we know that that sequence follows a pattern then. A sub n equals a sub 1 plus n minus 1 times the common difference. Now we must pick apart the information that we are given so that we can substitute those values into our expression here that defines any given arithmetic sequence. To do that, we're going to have to try and find a sub 1 and the common difference. Well, here it's pretty easy because they already gave us the common difference, d equals 4, so we can substitute that in right now if we wanted to. So that's not too bad. Now how are we going to find our a sub 1 value? Well, that's where this given term comes into play. We know a sub 4 is equal to 16. That means for the n value of 4, we have 16. So a sub 4 equals a sub 1 plus 4 minus 1 times our value of 4. We also know that a sub 4 is equal to 16. Therefore, 16, get away from that eraser there, 16 is equal to a sub 1 plus 4 minus 1, which would be 3 times 4. And all that is left now is a simple algebra problem where I have to solve for the one remaining variable, a sub 1. Okay, 3 times 4 is 12, subtract 4 over the other side, so we get 4 is equal to a sub 1. Now knowing that our initial value, our a sub 1 value is 4, and our common difference is 4, we can write the rule for this particular arithmetic sequence, which would be a sub n equals a sub 1, which is 4, plus n minus 1 times our common difference, which is 4. Okay, let's look at another type of problem. Write a rule for the arithmetic sequence that contains the following two terms. A sub 8 is equal to 21 and a sub 10 is equal to 27. Notice we are not given the common difference this time. We are just given two terms. So to plug in values for our general rule, a sub n equals a sub 1 plus n minus 1 times our common difference, we need to figure out what our common difference is, and then we'll use one of these two terms, pick your favorite one, to help find your a sub 1 value like we just did in the previous problem. Okay, let's analyze these two terms. We have a sub 8, which is 21. We have a sub 10, which is 27. That means there has to be an a sub 9 in between. And by definition of an arithmetic sequence, we know that you take 21 plus a number to get your a sub 9 term, and you take a sub 9, you add the exact same number to get your a sub 10 term. Well, if you look at the difference between 27 and 21, you know that that is 6. This value of 6 has to be evenly divided by these two common differences. So 6 divided by 2, which is equal to 3, is our common difference. And hopefully you can see how we came up with this value just by looking at the two terms. We have 27 minus 21, which is our 6 value. Then our sub numbers here, our subscript numbers, 10 minus 8, and that's how we got our 2. You don't have to write this up every time, but I thought I'd show this for you. So we came up with our common difference, which is 3. Now we have to use our common difference and one of these terms to calculate our a sub 1 value. Okay, I'm going to use a sub 8 equals 21, which means n is 8. It means this would be a sub 8, which is equal to 21. Right here at the end, we will substitute the value 8, and our common difference is 3. So now we have 21 equals a sub 1 plus our n value, which is 8 minus 1, and our common difference is 3. Solve this rather simple algebraic expression, and you get 21 equals a sub 1 plus, looks like 7 times 3 is 21. Isolate your a sub 1 value, and it looks like a sub 1 is equal to 0. Therefore, our rule, which is our expression, the explicit expression for the arithmetic sequence, now becomes a sub n, which is equal to a sub 1, which is 0, plus n minus 1 times our common difference, which was actually 3. Erase that. Now, to rather simplify this up, get rid of that 0, I'm going to rewrite this as just then n minus 1 times 3. Now, let's look at these two terms that come from an arithmetic sequence, and let's try and figure out the common difference rather quickly. Well, if we know that there are a sub 2 is 25, a sub 7 is 50, to come up with the common difference, we know that there has to be a range of 50 minus 25, that range of numbers, divided by the range in terms, which would be 7 minus 2. Would be 25 over 5. That equals to 5. So therefore, our common difference in this particular sequence that these two terms came from is 5. Well, let's look at some geometric sequences now. Write a rule for the geometric sequence that has a common ratio this time of 2 and a sub 6 equal to 96. Because this is a geometric sequence, we know that it follows the pattern a sub n equals a sub 1 times our common ratio raised to the n minus 1 power. So to complete this rule, we need to know our a sub 1 term and we need to know our common ratio. Well, here our common ratio is given to us, which is 2. We're also given that a sub 6 is equal to negative 96. That means that n, when n is 6, for the 6th term, we know we have negative 96. So any place you see n over here, you substitute with 6. A sub 6, well, that's equal to negative 96. So I'm just going to write negative 96 right away. The only variable we have left is a sub 1. We can solve for a sub 1 then, and then use that value to write our rule for this particular geometric sequence. All right, so well, that would imply then that negative 96 is equal to a sub 1 times 2 to the 5th power, which means that negative 96 is equal to 81 times 32. Isolate a sub 1 divided by 32, which means that a sub 1 is equal to negative 3. We know what our common ratio is, we know what our a sub 1 value is, so now we can write the rule for this geometric sequence, which would be then a sub n is equal to negative 3 times our common ratio 2 to the n minus 1 power. Now here's another problem. Write the rule for a geometric sequence that contains the following terms: a sub 2 equals 2 and a sub 5 equals 16. This problem can be a little more difficult than the arithmetic sequences that we are looking at. Let's look and see what's happening here. We know that a sub 2 is 2. That means we have to have an a sub 3, and an a sub 4, and then an a sub 5, which is then 16. Because this is a geometric sequence, we know that we have 2 times some number, the common ratio, times the common ratio again, times the common ratio again, has to equal 16. That means that 2 times r cubed is equal to 16, or our ratio cubed is equal to 16 divided by 2, which means our ratio cubed is equal to 8. You take the cubed root of both sides, and our ratio is then equal to 2. If we look at that again in a different way, we see that our ratio to the 5 minus 2 power is equal to, well, what does a geometric sequence have? A ratio. What's a ratio? It's a fraction, 16 over 2. And you will see then that we will come in right at that step right there. So we figured out that our common ratio is 2. Now what do? Well, just like the previous problem, take your common ratio and one of these terms, either a sub 2 equals 2, a sub 5 equals 16, and compute what a sub 1 is equal to. So we know this is a geometric sequence. It follows a pattern. A sub n equals a sub 1 times r to the n minus 1 power. I know that our common ratio is 2, and because this term comes first, I'm going to use that one. It means n is equal to 2. Our a sub 2 value is equal to 2. So if n is 2, this is a sub 2, which is then equal to 2. Our a sub 1 value, we don't know what that is. Our goal here is to calculate that value. Our common ratio is 2. We calculated that. Our n value is 2. A lot of 2's happening here. Now we have substituted what we know into some variables. We have one variable left to solve this equation for that variable. Well, that would imply then that 2 is equal to a sub 1, 2 to the first power, which is just 2. Divide 2 over to the other side, and we have a sub 1 is equal to 1. Therefore, our rule for our geometric sequence is a sub n is equal to a sub 1, which is 1, times our common ratio, which is 2, to the n minus 1 power, and we can clean that up a little bit, saying that it's just now 2 to the n minus 1 power. Okay, let's take one last problem to practice on. This is a geometric sequence. These two terms come from a geometric sequence. Let's practice finding the common ratio. Like before, we knew that there is an a sub 3 term, a sub 4, a sub 5, a sub 6, which means that the a sub 3 term is negative 32 times some number times some number times some number, which is then equal to negative 2048. Well, we know that 32 times r, then times r, then times r again is equal to this value. So therefore, negative 32 times r cubed is equal to negative 2048. Negative version of the popular game right now. Divide by negative 32. R cubed is then equal to 64. and then take the cube root of 64. Therefore, our common ratio is equal to 4. The other way to do this problem would be to say that our common ratio raised to the 6 minus 3 power, how many ratios we have multiplied, is equal to negative 2048 over negative 32. Which brings us straight back to the problem right here, and we get the exact same common ratio. We would use that common ratio and one of these points to write the rule, I should say one of these terms, to write the rule for our geometric sequence. All right, thank you for sitting through the next 2 videos in our sequence of videos dealing with sequences. Hopefully get the glitch figured out with this pen on this little tablet. If you happen to be out of class or you want to look at the videos again, hopefully I will have them uploaded to YouTube shortly. And I know I need to add clip art, whatever. And feel free to follow Mr. Bondley Math on Twitter. Have fun with your homework.